In this video, we'll use the GS4 Sleep Mode 3 with a forward acting PID loop. That controls the motor by watching the sensor feedback signal, or process variable, to decide when to turn the motor on and off. Forward acting means as the motor runs and the water rises, the sensor value also rises, and the PID will automatically control the motor speed for us. Reverse acting is when the sensor value goes down as the water level rises. We'll do an example of reverse acting in the next video. We're using the exact same hardware, motor parameters, and analog setup as in the previous videos. The first video in the series explains all of that, so we won't repeat it here. Now please remember, Sleep Mode requires firmware version 1.30 or later. Now keep in mind, this isn't really your typical PID thing, is it? Normally, PID is used to get a process to some level and automatically hold that level regardless of load. We're not doing that. Instead, we're just going to leverage the PID function to automatically control how the motor operates while it's filling the tank. That is, when Sleep Mode enables the frequency output to the motor, PID will see that the water level is way off, and it will automatically try to get the water level back to the set point as quickly and efficiently as possible. But Sleep Mode is going to cut the motor off before it gets there. So we're just using the PID function to automatically control the motor speed while filling the tank. These are the PID parameters we're using. This is where we tell the drive this is a forward-acting system using an analog input, and that for this demo we'll only enable PID in remote mode. The keypad is the default set point source. I'm just showing it here as a reminder. There's a separate video showing how I came up with these PID coefficients and why we're using this independent PID mode, so we won't repeat that here. Look for the GS4 PID video on tank filling to see how I did that. So now we just set the Sleep Mode parameters. First, we need to tell Sleep Mode to use the process variable, or sensor feedback, to make its decisions. Now this is important to understand. In Sleep Mode 3, the sleep and wake levels are not absolute. They're a percentage of the set point. So if we set the sleep level at 95%, that means the drive will turn the motor off when the water level reaches 90% of the set point, not the tank level. And it's the same for the wake-up level. This is 50% of the set point, not the tank level. Now that's really cool, because if we change the set point, the sleep and wake levels will automatically adjust relative to that new set point, which means we don't have to adjust the sleep and wake levels each time we change the set point. There's just one more thing to do. When the drive turns the motor off and the water level falls, the PID algorithm hasn't gone away. It's still trying to get the water level to the set point. Of course it can't, because Sleep Mode turned the motor off, which means the integral term will continue to grow the entire time the drive output is sleeping. So when Sleep Mode wakes the motor up to start pumping again, it's going to take a long time for PID to settle out because it has to wait for that integral term to settle out. This parameter lets you put a cap on how big that integral term can get. Now how bad that gets depends on your system configuration. The default value we have here works fine for this system, so we'll just leave it there. I just wanted to make sure you knew you had the option available to you if you needed to use it. We'll come back to these guys later. Just note that the delays are at the default 0 seconds and that the min drive speed is set to 30 Hz. Well, great. PID is set up to control the tank filling, and Sleep Mode is set up to cycle the motor on and off at these levels. Let's bring up the GSoft2 scope function and set our potentiometer values to mark the sleep level at 90% of our 95% set point, which is 85.5%, and the 50% wake level, which is 47.5%. So now we can see if things change when we expect them to on the GSoft2 scope. By the way, you can show this LCD set point in percent using parameter group 8 if you want to. We're not going to take the time to do that, but you can do it if you want to. Make sure the drive is in remote mode, since we told the drive to only do sleep mode while in remote mode back in parameter 7.0. Turn on our water level LEDs to make that easier to see, and hit run. The water tank is starting empty. PID sees that and automatically increases the blue output frequency to the max 60 Hz to start filling the tank as quickly as possible. But before PID can reach the 95% set point, the yellow water level, or process variable, hits the red sleep level, and Sleep Mode disables the drive's output frequency, which ramps back to 0 Hz at the deceleration rate we set. Let's open the valve to simulate demand. We see the yellow process variable fall, which tells us the water level is falling. when it hits the wake-up level, PID kicks in and cranks up the blue drive output frequency to fill the tank back up. I closed the drain valve to speed things up a little bit. When sleep mode sees the yellow process variable, or sensor feedback, reach the sleep level, it turns the output frequency off, which ramps down at the deceleration rate we set. If I open the valve again to let the water level fall, the process repeats. This will now run over and over again, simply because we turned on sleep mode by setting the sleep and wake levels. Not bad at all. Now remember we said the sleep and the wake levels are relative to the set point, right? Let's change the set point to 80% and see what happens. I'm going to leave our cursors at the 95% set point values so we can see the difference. Hit run, and sure enough, sleep occurred at 90% of the 80% set point, and wake up occurred at 50% of the 80% set point. Exactly what we expect. You can also delay wake and sleep to make sure the process variable is really past the level before sleep acts. Let's add a 2-second delay to the sleep, and let's add a 2-second delay to wake up. Hit run, and sure enough, wake up was delayed by 2 seconds. And uh-oh, what happened here? Well, sleep kicked in immediately, but it held at this minimum drive speed while it waited for the 2-second delay before shutting down. That's so you can control the drive speed while you're waiting for the delay to time out. When the delay was 0, there was no wait time, so the drive went directly to 0. That's why you didn't see this before. Did you notice that PID is pushing this drive really hard to get the tank filled back up? What if you don't want the motor to run at the full 60 Hz? Well, just set the PID output frequency limit to whatever you want. Let's set that to 75% and hit run. Sure enough, the motor's output frequency is limited to 75% of the full 60 Hz, and it takes longer for the tank to fill. Exactly what we expect. Well, that ought to be more than enough to get you going with Sleep Mode 3 with a forward-acting sleep mode. In the next video, we'll do the exact same example, but for a reverse-acting system. That is, the sensor value goes down as the water level rises. Click here to learn more about the GS4 drive. Click here to learn about Automation Direct's free support options, and click here to subscribe to our YouTube channel so you'll be notified when we publish new videos.